The public lecture that I attended was on the topological ideas behind the 2016 Nobel Prize in Physics. The presenter was Dean Paul Goldbart. A little bit about the topics of the lecture, which features topological phase transitions and topological phases of matter. A phase transition of matter, for example, is when ice melts or water turns into gas. Topologies of matter are essentially properties of the matter that do not change when it's twisted, stretched, or deformed. While I was listening to the lecture, I didn't really understand what was happening, but upon researching some basic ideas of what the Nobel Prize was awarded for, I came to a better understanding of the research. So basically, there's this idea of the quantum Hall effect, which is where there's a thin layer of electrons at a very low temperature. The electric conductivity of this thin layer of electrons could be measured with high precision at certain steps or levels of conductivity. And the big question was, why were the measurements so precise? This is where the Nobel Prize in topology comes in. The Nobel laureates discovered that the steps of conductance could be explained as a topological invariant. Another part of the research that was awarded the Nobel Prize goes over the idea of topological phases of matter and phase transitions. Before, it was believed that if you had a two-dimensional layer of liquid helium, you can't have phase transitions, and this was proved mathematically. But the researchers showed that in a two-dimensional layer of liquid helium, there are actually vortices that exist in pairs at low temperatures, and if you raise the temperature, the vortices will drift and move, which is considered as a phase transition driven by topological effects. Tying everything back together, we can see that if we take topological phase transitions and combine them with electric conductivity and the Hall effect, we can ultimately create better computers. This is because superconductors need really low temperatures to work well. But if we are able to increase the temperature yet maintain topological properties of matter, we can perhaps have efficient superconductors at room temperature, which is amazing for making faster computers because more conductivity means less resistance, which means faster computing. Thanks for watching!